Welcome to Starbase, Texas, a small strip of Gulf Coast land at the southern tip of the United States, and until not long ago, almost entirely unknown. Today, however, it is arguably the most consequential piece of real estate in the history of human spaceflight. This is where SpaceX is building the vehicle it intends to send to the moon, to Mars and beyond. And this is where, before any of that can happen, something extraordinary takes place. Not in the sky, but on the ground. This is the story of the machines that make it all possible. Not the rockets, not the engines, the transporters. You guessed right. The slow, silent giants that carry the world's largest rocket to the pad one careful meter at a time. To understand why these machines matter, you first have to understand the problem. The Starship launch system, SpaceX's flagship vehicle, is the largest rocket ever built. When fully stacked, the combined Super Heavy booster and Starship upper stage stands approximately 121 meters tall, taller than the Statue of Liberty, taller than a 40-story building, and weighs around 5,000 metric tons fully fueled. It cannot be transported horizontally and then raised, because it's assembled, inspected, and integrated vertically. So when it's time to move it from the production and integration facility to the orbital launch pad, it must travel upright. Like a needle threading the sky down a road that is barely wider than the vehicle itself. You can't just strap it to a flatbed, you can't tip it on its side, you certainly can't ask it to walk, so the question becomes, how do you move a 70-meter steel skyscraper down a road without it falling over, cracking, or simply refusing to cooperate? That job belongs to the SPMT, the Self-Propelled Modular Transporter. The concept is deceptively simple. A flat platform held aloft on a forest of individually steerable hydraulically suspended axles, powered by an onboard diesel engine. Each axle can rotate independently, meaning the entire platform can translate sideways, spin in place, or crab diagonally across the ground with the precision of a surgeon. But simple is relative. The engineering that makes this possible is anything but. The history of the self-propelled modular transporter begins in the early 1980s, when heavy haulage company Mammoet recognized the need for something the world didn't yet have. A transport platform that could handle truly extraordinary payloads. Offshore oil platforms, reactor vessels, massive bridge sections, without needing a purpose-built road or a dedicated crane. They commissioned a German engineering company to build it. That company was Scheuerle. Now, if you were going to trust anyone to engineer a machine for moving the heaviest things on Earth with millimeter precision, you'd probably want a company with more than a century of experience from a country with a well-established reputation for building things that work extremely well. Scheuerle, founded in the mid-19th century in the town of Feldbach in southern Germany, ticked both of these boxes quite comfortably. Their commission from Mammoet would define their legacy. The first SPMT units were delivered in 1983, and they set the standards that still define the industry today, with a modular width of 2.43 meters, sized to fit inside an ISO shipping container flat rack for global deployment, and a fully computer-controlled 360-degree steering system that no competitor had yet achieved. 4 decades later, the machine that SpaceX trusts to carry its moon rockets across a Texas road is the direct descendant of that original design. Which is either a testament to how well Scheuerle got it right the first time, or a reminder that moving very heavy things very slow hasn't changed all that much. Probably both. At Starbase, Texas, SpaceX operates Scheuerle's SPMT units in combined configurations. Multiple individual module sets linked together both mechanically and electronically to form a single platform capable of carrying loads that would otherwise require purpose-built infrastructure. Each individual Scheuerle SPMT module can be configured with 3, 4, 5, or 6 axle lines. Each axle line is capable of carrying up to 60 metric tons of load depending on the variant. The platform itself is 2,430 millimeters wide and rides on a dense grid of hydraulically linked bogie assemblies. Each bogie connected to a swing arm and a support cylinder that continuously adjusts to keep the load surface level regardless of what the ground beneath is doing. The power pack unit is the heart of the system. Scheuerle's PPU is driven by an 8-cylinder Daimler OM502LA diesel engine, providing the hydraulic and electrical power that feeds every function. Everything from steering, suspension, and drive. It sits on a separate subframe connected to the platform laterally and includes a tilt cylinder system that allows the PPU itself to adjust on inclines while keeping the load deck perfectly flat. The entire system is governed by Shoyale's proprietary Salsa software, which despite sharing its name with a type of dance, is in fact a very serious piece of engineering. It manages axle coordination, steering programs, and load distribution in real time. Operators can switch between driving modes such as standard, circular, diagonal, and transverse from a remote pendant controller while walking alongside the load as it moves. Positioning accuracy for the Shoyale SPMT is rated at plus or minus 1 to 2 millimeters, not centimeters, millimeters. For context, that is roughly the thickness of a credit card. When you're placing the base of a 200-ton rocket onto a launch mount with bolt patterns that must align perfectly, that kind of precision isn't a luxury, it's a requirement. Getting it wrong isn't really an option, at least not one that anyone would like to explore. The Shoyale SPMT's modularity is one of its most powerful features. Individual modules can be coupled together, side by side, end to end, or in any combination. In just 3 mechanical steps, using the standardized horizontal lamellar coupling system built into the underside of each platform. The onboard electronics automatically detect and integrate newly added modules, recalibrating the load distribution across the expanded axle network without requiring manual reprogramming sessions. It's essentially plug and play, if plug and play meant connecting several hundred tons of German industrial hardware under a rocket. This modularity means that as SpaceX's vehicles grow, and they are growing with each new block revision, the transporter configuration can be scaled to match. The only real limiting factor now for SpaceX is the size of their roads, and as you can see on this footage, it's already getting kind of close. The payload is, in Shoyale's own words, infinitely scalable, which is a very polite way of saying, however large SpaceX decides to make this thing, the SPMT will figure it out. A Starbase rollout is one of the most visually striking events in modern aerospace, not because of fire or sound, but because of its improbable stillness. The Super Heavy booster in its current Block 3 configuration stands 72.3 meters tall and is 9 meters in diameter. Constructed from 304 low-carbon austenitic stainless steel, it houses 2 giant cryogenic propellant tanks, a liquid oxygen tank and a liquid methane tank, together capable of holding 3,400 metric tons of propellant. At the base, 33 Raptor engines, each producing over 2 meganewtons of thrust, are arranged in 3 concentric rings. It is by any reasonable measure a hell of a lot of rock. The Shoyale SPMT configuration at Starbase is arranged to distribute this load across enough axle lines to keep ground pressure within the limits of the facility's reinforced concrete roadway. Each of those axle lines doing their share of work, hydraulic pressure equalized across the entire grid. Nobody wants to find out what happens to a road that isn't up to the job. The journey from the build site to the launch pad at Starbase is relatively short, roughly half a mile, but it's a journey that is never treated as routine, because as you can see, there's quite some maneuvering to do when your vehicle is 9 meters wide. As the booster clears the building and moves out onto the road, the full scope of the operation becomes apparent. Escort vehicles flank the transporter, a perimeter has been established, the booster's base is about a meter off the ground, held there by hydraulic pressure, perfectly level as the road's minor undulations pass silently through the axle network below. What the camera can't convey, however, is the sound, which is why I'm going to play some for you. Upon reaching the launch site, SpaceX's orbital launch pad, the SPMT configuration must perform its most delicate maneuver, positioning the booster directly underneath the chopsticks, with millimeter precision. This is where Shoyale's positioning accuracy of plus or minus 2 millimeters becomes the entire point. The launch mount's mechanical interface must engage cleanly, misalign it even slightly, and the operation stops. The crew resets, and then they try again. There's no rushing this part. The Starbase operation is only the most visible chapter in a long global story. Shoyale's SPMTs have transported 23,000-ton ships on 880 axle lines. They have moved entire hotel buildings. 7,500 tons of concrete, steel, and glass, 500 meters down a street in China. A feat claimed as the heaviest building transport ever recorded. In Norway, 748 axle lines of SPMT were used to load an offshore production vessel onto a decommissioning barge. At some point, the list of things an SPMT has moved becomes shorter than the list of things it hasn't. Each of these operations relied on the same core principles: modularity, hydraulic load distribution, computer-controlled multi-axle steering, and the compactness that allows an SPMT fleet to be shipped flat rack inside of standard ISO containers and deployed anywhere on Earth. The Schoyle SPMT's steering system is a marvel in its own right. Each axle can rotate through 270 degrees, some configurations offering up to full 360 degree. The vehicle can perform standard drive, circular turns, crab diagonal movements, or full transverse sideways translation, in which the entire platform moves laterally without rotating. It can, in short, go in directions that most vehicles have never even considered. A bus driver watching an SPMT perform a full transverse slide would likely have questions about their career choices. For Starbase, this agility is essential. The geometry of the facility, the relationship between the high bay building, the road, and the launch tower requires the transporter to make turns that a fixed axle vehicle simply couldn't execute. The SPMT does it quite precisely and repeatably. That discipline is a thread that runs through everything at Starbase. SpaceX operates at a tempo that can seem breathtakingly fast compared to traditional aerospace. Rapid iteration, frequent testing, acceptance of calculated risk in flight. But the ground operations that support those flights are governed by the same industrial conservatism that moves oil platforms and decommissions ships. On the ground, there's no such thing as move fast and break things mentality, mostly because the thing in question weighs several hundred tons and is filled with rocket engines. As SpaceX's ambitions expand, more launch sites, higher flight rates, eventual Starship missions to the Moon and Mars, the logistics infrastructure that supports them will have to scale accordingly. Larger vehicles, more frequent rollouts, potentially multiple transporter configurations operating simultaneously across different pads. So it seems like the SPMT has a lot of work ahead of it, especially in SpaceX's yard. In the grand calculus of space exploration, the SPMT rarely gets a mention. It has no engines that light the sky, it makes no sound that travels for miles, it's not fast, it does not go to orbit, and it will never appear on a mission patch. But every mission that leaves Starbase Texas begins with a machine that rolls, a machine that speaks in millimeters, a machine built in a small German town, refined over 4 decades, and now tasked with carrying the vehicle that its makers hope will one day carry human beings to another planet. Before anything can fly, something has to roll. I hope you enjoyed, so please leave a like and subscribe, and thanks for watching.